Hello everybody, and welcome to the next video on functions. In this video I will cover two things. The first topic will be vectors with regard to functions, so giving a vector to a function or having a function return a vector. You can do either, or you can do both at the same time. And also the idea of passing a variable by reference, which we'll get to at the end of the video. So first, let's just recall how you declare a function. This is the first thing you have to do before you build something. The first thing you do is decide what kind of thing the function will give back to you. So you have to decide, am I going to give true or false back? In which case you would type bool. Am I going to give an integer back? In which case you would type int. Am I going to give nothing back? In which case you would type void. Right, whatever. Then you name the function. Then you tell the function everything you are going to give it. So maybe you are going to hand it 2 strings and also an integer, as we did last time with the find function. Maybe you're going to hand it 8 integers and compute their average. Who knows? But you have to tell the computer how many things you're giving it and what their data types are. And so, of course, all of that to say, there's no restriction on this data type. There's no restriction on the kind of thing you can hand to it. So this data type could be an integer vector. You could type right here vector int, and then what you're telling the computer is that you're going to return an integer vector. You're going to give a list back. Okay, so again, if you type vector int right here, you are saying to the computer, no matter what I hand you in here, you are going to give me a list back. And of course, you can also hand the function a vector or a series of vectors, whatever you want. You can give a function whatever you want. You can make the function return whatever you want. And we've already seen an example of this, taking a vector as a parameter. We did that last time when we handed vectors to print functions, those void print functions. So let me just point out that we've already printed a vector. We did that last time. That was a void function that accepted a vector as a parameter. So the examples we're going to do now, I'll do 3 of them in fairly quick succession here. We're going to calculate a median, so write a function that does that. So to do that, you of course have to hand the function the vector you want it to calculate the median of. Then we will compute a divisor list given a number, and then we'll compute a list of common divisors given a list of numbers. So first, let's start with the median function. What would that look like? Well, you have to hand the function the list you want it to compute the median of. If this function is going to do its job, you have to first hand the function the list you are interested in. And then the median may be a decimal even if the values of myvec are integers, because sometimes a median is an average of 2 values. So here's the setup of the function. I'm going to hand you a single list of integers. The thing is called median, and what it's going to give back is a possible decimal. Okay, so let's come to the compiler here. I've already set up getting a list from the user. So now let me just come up here and type float median. I'm going to give you function an integer list. Okay, so now we just have to come down here beneath main and write the code that will do this. Get rid of this. So given a list, how do you compute the median of that list? Well, you guys have done this already, haven't you? So let me essentially I'm just putting the same code we had before. Sort list.begin, list.end. If you want to calculate a median, the first thing you got to do is sort the thing. And again, ignore the red. You haven't returned anything yet, so if you want it to go away, you can have it return something, But anyway, it's just saying you haven't returned something yet. So you got to sort, okay, and then if list.size is even, is odd. Let me do odd first. So %2 not equal to 0. Then the median occurs right in the middle, And the way you can get that is take list and do list.size integer division by 2. Okay, so what is this saying? This is saying that, look, if your size is 7, do 7 divided by 2 integer-wise, which gives you 3. So this number would then be 3, and what you're saying is, give me back the item inside of list at position 3. So the entry inside of list at position 3, and that is indeed where the median will be after you've sorted a list of odd size. Otherwise, you need to return an average of a couple of things. Okay, so you're going to take list.size, again divided by 2, but now you have to average the two middle guys. So let me just do that average. So now I have to average with the next guy, list.size, next guy over, close parenthesis, divide by 2, and now I have to do integer division here because I'm taking a legitimate average. So back up here in main, let's just make sure this works. Like, hey, tell me what the median of this list is. All right, print that to the screen. And again, look how nice this is. It's just English, right? Print to the screen for me the median of this list. And you've outsourced the median code out of main. And so again, this may or may not look like the code that you wrote for your homework problem, but that's fine. You would just put your code in here and return whatever thing you did, right? I mean, you can just, essentially that's all you're doing is copying and pasting code down when you're using a function. Okay, so let me give it a list like 1, 2, 3, now I'm done. It says the median is 2, that's what it's supposed to be. Now let's do like 2, 1, 3, 4, now I'm done. Whoa! Oh, yeah. Sorry, so I want to take this position and increase it by 1. So I had that division by 2 missing there. So let's try that again. 2, 1, 3, 4. 3.5. Oops, so I went too far, didn't I? Like that. All right, 2, 1, 3, 4, done. 2.5. Okay, good. Yeah, so sorry about those two typos there. Those of you who did code just like this, you did indeed remember to put a division by 2 there and subtract 1. So go to the middle, but the middle now is 1 too far. So just average it with the guy right behind him. Those are the two middle values. Okay, so here's a function that will return the median of a list of numbers. Okay, so now let's move on to computing a list of divisors of a given number. So what does that mean? That means that I'm going to hand the function a number. Let's say the number is 8. What the function is supposed to give back to you is a list of that number's divisors, which in the case of 8 would be 1, 2, 4, and 8. So I'm going to hand you 8, and what you give back to me is the integer list 1, 2, 4, 8. So let's think about what that would look like in the code. So first of all, you're telling the computer, hey, what you're going to give me back this time is an integer list. And what I'm going to give you this time is just a single number. So as opposed to this, right? Like here you were handing it a list, it was giving you a number back. Now you're handing it a number, it's going to give you a list back. Okay, so let's build the function here. Again, let me create some space. Okay, so first, let's just create an integer list that we're going to hand back. So divisor list, maybe, call it whatever you want. And so how do you create divisor lists? Well, if you want to calculate the divisors of A, you all have written this sort of for loop before. You just start at 1, go all the way up to A, and every single time you get a divisor hit, go ahead and put them right in there. So if A is a multiple of what I'm currently looking at, right, that's what this is saying. If I is a divisor of A, or if A is a multiple of I, however you want to say it, then what you should do is divisor list. Go ahead and put that I value right in there. So notice, since 1 is a divisor of A, no matter what A is, the first thing that happens is you throw 1 into this list. And then if A were 8, or had value 8, then I would become 2. 8 is a multiple of 2, you would throw 2 in there, etc. And then what you're going to do is return divisor list. So you're going to give a list back. So that back up here in main, let me just comment this out for a second. Okay, so int n, let's just get a number from the user. And now, if I feed that n value into this divisors function, I will get a list back. So to verify that the list is correct, I should print it. So let's just, and notice I have my print function still here from last time. So let's just print 1D vector. Which vector do we want? I want the divisors list of that n value. Okay, so again, what's happening here? N is a number. You feed that number into the divisors function. What you get back is a list. Therefore, divisors of n is a list, and therefore we can print that list. So there's nothing confusing going on here. Notice if I were to, suppose I did this. Okay. Now the computer is not happy. The reason it's not happy is because n is an integer, n is not a vector, and this function is expecting you to hand it a vector. And so notice when I do divisors n, well, divisors of n is a list. It's the list of the divisors of n. Okay? And so again, look at how nice the functions make the English flow here, right? I want you to print a vector for me. Which vector? Well, the divisors of n. That vector, you know? It's nice. So let's just put 8 in here. Oops, here we go. It prints 1, 2, 4, 8. Okay, as it should. Let's put, 17 in there. Only 2 divisors because it's prime. Okay, so before I do the final example, let me just point out that this issue that I just had a second ago, like writing something like this is a very common error, simply because it gets hard to keep track of, okay, what kind of thing is this? Right? What is that? Well, it's a list. It's a return value of divisors after you put n in there, So it can become very confusing to keep track of the data types of everything. And again, if you do this, you're not handing this function the data type at once. That's why it's yelling at you. Or by the same token, if I were to do like this, if I were to, let me get this. If I were to be like, median of n or something, right? This thing would say, I don't know what you're talking about. Median accepts a list. You have not handed me a list. Or maybe, what if I were to do this? Divisors list. The thing yells at you again because it's like, divisors accepts just a single integer number, right? That's what divisors takes as input, but you're trying to feed it a vector, and a vector is not the same thing as a number. So all of that to say, you have to keep track of the data types very closely, right? So this, what I had here, print 1D vector divisors n. This is a composition of functions, right? I feed n into divisors, and the result of that is fed into this function. So all of this to say, function composition can be confusing because domains and ranges have to line up in the appropriate fashion when you compose functions, and that can be hard to keep track of. Okay, so my final example of vectors inside of functions is this. This function will take a list as input and give you a list back. So the parameters and the return value are vectors. So here's what it's supposed to do. Compute a list of common divisors given a list of numbers. So to be precise, I want to give the function a list of numbers, the function then returns a list of common divisors. So what does that mean? Suppose I hand the function this list. What I want the function to do is give me back all of the numbers that are divisors of all of these numbers here. So notice 1 is a divisor of 6, 12, and 13. So I want 1 to be included in what I get back. Notice 2 is a divisor of all of 6, 12, and 30, right? 3 is a divisor of 6, 12, and 30, etc. But notice there are no more common divisors. So, for example, 6 is a divisor of itself and 12. Oh, whoops. I just immediately contradicted myself. How foolish. Yeah. I should give back here the list 1, 2, 3, 6. Anyway, so sorry, that's a typo here. 1, 2, 3, 6 is what I should get back. Okay, but anyway, moving on. I should not give back the number 12, because while 12 does indeed divide itself, 12 does not divide 6, it does not divide 30, right? And think about a number like 5. 5 divides 30, but 5 does not divide 6 or 12. So anyway, the list I should get back is 1, 2, 3, 6, the list of numbers that divides everything in this list of numbers. Okay, so what this function will look like is I'm going to give you a list back and call it whatever you want, but here's something suggestive. And what I'm going to give you is a list of numbers. Oops. Okay, so let's build this now. Wherever, here we go. Now the question for you is, if I give you a list of numbers, how exactly do you compute the list of common divisors? So let me just first declare that. Common divisor list. How exactly do you build this list? What would that even look like? Well, essentially what you need to do is for int I equals 0, I less than or equal to something, I plus plus. And I think it's clear what this less than or equal to something is. In this case here, you'd want to go all the way up to what? You could stop at 6, right? Anything after 6 is too big. So really, if you're going to start computing common divisors of all 3 of these numbers, you really only need to go up to the smallest number. Because as soon as you pass the smallest number, you can't divide the smallest number anymore. So the first thing we should probably do is sort this list, right? Oops. Yes, sort list.begin, list.end. And once we've done that, we know the smallest number is at the beginning. So let's just go up to that smallest number. Because again, you don't need to check anything past 6. We know immediately that 8 doesn't divide 6. Therefore, 8 can't be a common divisor inside of this list. And so actually, there's nothing wrong with going up to the biggest number also. Like you could put list, whatever you have to figure out the size, right? List.size -1. You could do this also. There's nothing wrong with that. It's just you don't have to go that far. Okay, so you want to start at, 1. And what you want to do is just check whether or not each of these I values is a divisor of like 6, 12, and 30. Okay, so how do you do that? Well, it seems like the best thing to do would just be to create a variable that keeps track of this. So for a given I value, we need to check whether or not I divides everything inside of list. So what would that look like? So for int j equals 0, j less than list dot size j plus plus. How about let's do something like this? J less than list. Yeah, oh, oops, okay, semicolon. Let's do something like this. If, what? This way. This dot j is a multiple of what I'm currently staring at. Then we'll up the count. Okay, so what is this doing? This is saying, look, I'm going to go through my entire list, right? This list that I've handed you. I'm going to run through the entire list, start at position 0, go all the way to the end. If what I'm currently looking at inside that list is a multiple of this I value that I'm currently considering, so again, I'm going to start by considering 1 and ask, like, is 1 a multiple or a divisor of 6, 12, and 30? So when I is 1, that's all I'm doing. I'm just asking, like, hey, is 1 a divisor of everything inside of this list? And if it is, I'll up the count. And then at the end of this, you know that if count is the size of the list, so in other words, you got hits every single time, then what you should do is record I as a common divisor. So common divisor list.pushback, throw I in there. Okay, so again, this is probably confusing. Any sort of nested loop structure has the potential to be confusing, but what you're saying is I'm going to consider numbers 1 at a time until I get to the smallest number in my list. Fixing one of those numbers, like fix the number 2, what I'm then going to do is just go through all the numbers in the list and ask, is 2 a multiple of the guy at position 0? Is 2 a multiple of the guy at position 1? Is 2 a multiple of the guy at position 3, etc.? And every time I get a divisor hit, I'm going to up the value of count. The reason that I'm upping the value of count is because then, if count actually reaches list.size, that means you got a divisor hit everywhere, which means you had a divisor in common. So I just want to make sure I reset count to 0 every time, right? So that then when I clicks up to 3, I goes up to 4, whatever, you've reset your count value. And when all this is done, we can return common divisor list. Okay, so let me come back up here to main. I'm going to get a list from the user, and I'm going to print a 1D vector. But in this case, the vector I'm going to print is the common divisors list of list. Okay, so again, what's happening here? List is a vector. I'm handing that vector to the function common divisors, which takes vectors as input, and then I'm going to get a vector back. Therefore, this entire quantity here is a vector, and then I'm going to print that vector. Okay, so let's run this. So let's just enter that list, right? 6, 12, 30, done. Yeah, it says, oh, your common divisors are 1, 2, 3, and 6. Let's do something where we have nothing in common, 1, 5, 7 or something. Right, it just prints the number 1. There's only one common divisor. So, no matter what, 1 is going to be in there, right? Let's just do a couple more. So like 2, 6, and 7. 2, 6, and 10. Should just be 1 and 2. Yep, there you go. Okay, so notice down here, actually, before I leave this example, anytime you have a nested for loop structure, you could have outsourced this computation here to a different function if you wanted to, right? A function that just takes a single number, this I value, and checks whether or not it is a common divisor. So you could have built a Boolean function with this inside of it and return true if you had a common divisor of everything and return false otherwise. So again, even this function could call on a separate function if it wanted to. It just depends on how you want to build the thing, It depends on if you want your external functions to call on other functions. But in general, since nested for loops can be confusing, it can be helpful to just take this segment of code, outsource it somewhere else, and call on it. Okay, so those are my 3 examples with functions and vectors. I'm not sure why I think this is important. We already did some examples. Okay. So let me now finish by talking about passing by value or passing by reference. And so to do that, let me just build some sort of simple little function like int f and f's just going to take a single value. And it's going to do something real simple. It's just going to like take that value and let's just increase it by 1 and then return it. So back up here in main, let me just again comment all this out. So when the user gives you an n value, and actually let me just hard code something in. Okay, so x is 3, right? Let's just ask the computer what f of x is. Well, since x is 3, that 3 value gets passed to this a value. You know, a increases by 1 to 4, and then I get a 4 back. So what should print to the screen is 1 more than 3, which is 4. Right? If I increase that to 7, what should get printed is 8, you know. But notice this. Notice that if after I print that function value, I ask the computer like, hey, what is x? Like, you told me what f of x was, and again, f of x was simply, oh, the value of x gets passed to a, so then that 7 becomes an 8, and I give you an 8 back, right? So f of x here is 8. What is x? Well, the value of x certainly hasn't changed, you know, it's just still 7. Why would the value of x have changed? You haven't done anything to it. I mean, if you did something like this, right, then the value of x has changed. Okay, so what this function does, and what every function we've looked at so far does, it's an example of passing by value. So x, it's a variable, right? So it's like a storage space inside the computer somewhere. It's a box. That box has a 7 inside of it. When you do f of x, that 7 goes into this other box that's called a. So a is its own separate box, and the value of the x box is handed to the a box. So that a and x are both separate boxes. X had value 7. Oh, now a has value 7. That 7 becomes an 8, and then I give you an 8 back. Okay, to pass by reference, so everything I just said was true about passing by value. Let me just show you what happens here. Okay, so notice back up in main, there's no x++ or anything, right? So x is 7. I feed x into the function f, and then I'm going to ask the computer what x is. So let's just watch what happens here, because remember before, the computer told us that x still had value 7. Okay, x was 7, now x is 8, has value 8. Why would that be? You know, because all I did was, I didn't explain this, but all I did was add this little ampersand symbol, you know, so surely that had an effect on things. But what effect did it have? Well, when you add an ampersand, you are no longer just handing the value of x to a. That's what was happening before. A and x were separate boxes. I was just copying the value of one box and putting it in the other box. So that now you had 2 boxes, each with 7 in them. That's passing by value. When you pass by reference, this x box actually becomes this a box. So you don't even have 2 separate boxes anymore. A and x are now the exact same box. So here, when you increase the value of a by 1, since the a box is the same as the x box, they are now the same in memory, right? The same box inside the computer. When you increase a, the value of a, you also increase the value of x. So since a and x, their boxes are identified, they're glued together, whatever, they are the same. Anything that happens to a down here will also happen to x up here. That is why x started at 7, and just 2 lines of code later, the value of x is 8, because you fed x into the function f, and inside of f, a, which now literally is x. Their storage spot in memory is the same. A got increased by 1, and therefore x got increased by 1. And that's why you see an 8 right here when I ask it what x is. Okay, so all of that to say, to pass a variable by value means that only the value of the variable gets handed to the function. The storage space itself in memory, the box that is that variable, that box is left alone. You are simply copying and pasting the value of that box into a different box. The function creates a new box to store the value that has been passed. So without the ampersand here, what's happening is, up in main, x is its own box in memory. The function then creates a new box called a, and a is handed the value of 7, and then 7 becomes an 8, etc., right? But to pass by reference means to pass the variable itself, like literally where it is in memory inside the hard drive or whatever, not just the value of that variable. In this case, the function doesn't create a new variable at all because the function has already been handed a variable. In the example on the screen before, you've literally handed it x, the box x, the place in memory x. So what that means is, passing by value and passing by reference do different things. If you pass a variable x by value, the value of x is not changed in main. So after the function is done running, the value of x is the same. On the other hand, though, if you pass a variable x by reference, the value of the variable can be different in main, and oftentimes is, after the function is done running. So if you change the value of a variable in the function, that change is remembered back up in main. So again, by contrast here, where I'm not passing by reference anymore, I'm passing by value. X was 7, its value was 7. That 7 is passed here, and that 7 becomes an 8. The 8 gets returned. But since a is a different variable in memory, it's a different box, the fact that 7 became 8 is not remembered at this line in the code. But when I pass by reference, now x and a are the same, and therefore the change that was made to a down here is remembered up in main up here. All right, so x now has a new value. Okay. So as I say, like passing by reference remembers things. So just to show you a couple more examples of this, and I'm running short on time. I don't want to make this video too long. So your first natural question to me would be, what's the point of passing by reference? Okay, and we will get to that next time. Like, why would you even do this? Briefly, the answer is multiple fold. One reason you might want to pass by reference is because it costs memory to make copies of variables, right? So when you're doing this, you are creating a separate storage space, which costs memory. So when you're passing vectors, among other things, right? Vectors can be like tens of thousands of entries long. And so if you're going to pass that by value, which we're doing up here, right? To pass it by value, the computer then has to create a copy of that list of tens of thousands of values. So it costs like double the memory that it otherwise would. Okay, that's one reason, but we'll see other reasons later. I want to just point out real fast. Let me get this going. Back again. Okay, so let me get rid of all the X stuff. So where was median? So here I could pass a list by reference instead of by value. So median, where are you? Here, okay. So now, if I hand back up here in main, the first thing I do is I create a list, and then I give list to the function median. Print 1d vector list. So I'm going to hand this list to the median function. Let me come down here to median, and notice the first thing I do is sort that list, okay? Which when I passed by value has absolutely no effect on the list back up in main. So let me just, so I don't have to keep scrolling, let me put this up here. So let me just start by passing by value. So here we go. So I'm going to create the list, I'm going to compute the median and print it, and then print the list. So let me do, 2, 3, 1, 4. I'm done, all right? So it prints the median, which is 2.5, and then it prints 2314, the same list, right? 2314 is what I entered. It computed the median, and then it printed me that original list. But let me put an ampersand here, and then I have to put it here. And just to make this look nicer, let me put a new line after that median. Let me not run the same code again, but let me add, or sorry, let me do the exact same list, 2314, and now I'm done. Okay, the median is still 2.5. That of course hasn't changed, but notice what happened. My list changed. It used to be 2314, now it's 1234. It's different. It's been sorted. And the reason it was sorted is because it was sorted down in the function, and since you passed it by reference, that change was remembered up here. Okay? So, recognizing when you should pass by value versus by reference and being able to use functions that pass by reference, that takes getting used to, just like everything takes getting used to. So we will get more practice as we go, but for now, your takeaway from this video is twofold. You should be comfortable with handing vectors to functions and having functions give you vectors back, as we did in multiple examples, right? You should also at least be comfortable with the concept of passing by reference. And the big takeaway from that is changes that are made in the function are remembered back up in main, because you're now passing things in the memory of the computer itself. You are not simply passing the value of this variable. Okay.